Hello everyone and welcome to this video channel Science Class I. Today we are going to learn chapter number 16, light. So from this chapter we will study what is light and what are the different phenomena of light and laws of reflection of light. And actually there are two phenomena of light. They are reflection and refraction. So let's try to learn this chapter number 16, light. First let's read all this thing and what it says. Let's see. The world is largely known through the senses. The sense of sight is one of the most important senses. Through it, we see mountains, rivers, trees, plants, chairs, people, and so many other things around us. We also see clouds, rainbows, and birds flying in the sky. At night, we see the moon and the stars. You are able to see the words and sentences printed on this page. How is seeing made possible? So here what it says, the world is largely known through the senses. That is, the sense of sight is one of the most important sense, and through it we can see mountains, rivers, trees, plants, chairs, people, and so many other things around us. So we also see clouds, rainbows, and birds and flying in the sky at night, and we see the moon and the stars. So many things we can see around us. How can we see things? When the light ray falls on the objects and some parts of the light energy are reflected back, and its light energy forms image in our eyes at retina. You know, in the retina, two sensitive cells are there. They are rods and cones. They in the retina, image is formed. Thus we can see objects around us. So what makes things visible? Let's see. What makes things visible? Have you ever thought how we see various objects? You may say that I see the objects, but can you see an object in the dark? So here is one question. Have you ever thought how we see various objects? And you may say that I see the objects, but can you see an object in the dark? No, in the dark we cannot see object. It means that eyes alone cannot see any object. So it says only the eyes alone cannot see any object. So it is only when light from an object enters our eyes. So that is called reflection. So it is only when light from an object enters our eyes and that we see the object. So when the light ray falls on an object and some part of the light energy enters in our eyes and it forms the image of the object, thus we can see. So the light may have been emitted by the object or may have been reflected by it. So the object itself may emit light or may be reflected back from the object. You learn in class 7 that a polished or a shiny surface can act as a mirror. A mirror changes the direction of light that falls on it. Can you tell in which direction the light falling on a surface will be reflected? So let us find out. So you learn in class 7 that a polished or a shiny surface can act as a mirror. A mirror changes the direction of light that falls on it. So can you tell in which direction the light falling on a surface will be reflected? So let us find out it. Here, laws of reflection. So in the laws of reflection we will study two laws. They are first law and second law. So let's see here, activity 16.1. Let's see. Fix a white sheet of paper on a drawing board or a table and take a comb and close all its openings except one in the middle. You can use a strip of black paper for this purpose and hold the comb perpendicular to the sheet of paper and throw light from a torn through the opening of the comb from one side, that is figure number 16.1. With a slight adjustment of the torch and the comb, you will see a ray of light along the paper on the other side of the comb, and keep the comb and the torch steady. So here what it says, we have to fix a white sheet of paper on a drawing board or a table, and we can take a comb and close all its openings except all in the middle. Then you can use a strip of black paper or for this purpose, and you have to hold the comb perpendicular to the sheet of paper, and we have to throw light from a torch through the opening of the comb from one side. As we can see in the figure, with a slight adjustment of the torch and the comb, you will see a ray of light along the paper on the other side of the comb. And keep the comb and the torch steady. Place a strip of plain mirror in the path of the light ray. Figure number 16.1. What do you observe? Let's see. Here, figure number 16.1, arrangement for showing reflection. So arrangement, here we can see phenomenon of reflection. The light ray is reflected back here, we can see. Then after striking the mirror, the ray of light is reflected in another direction. So the ray of light is reflected to another direction. So this light ray which strikes any surface is called the incident ray. So this is called what? The incident ray. And the ray that comes back from the surface after reflection is known as the reflected ray. So incident ray and reflected ray, here we know incident ray and reflected ray. So we can understand after reading this, and I will also explain you. A ray of light is an idealization. In reality, we have a narrow beam of light which is made up of several rays. For simplicity, we use the term ray for a narrow beam of light. Here, a ray of light is actually an idealization. In reality, it is a narrow beam of light and which is made up of several rays. So, for simplicity, we use the term ray for a narrow beam of light. So, draw lines showing the composition of the plane mirror, the incident ray and the reflected ray on the paper with the help of your friends. Remove the mirror and the comb. Draw a line making an angle of 90 degrees to the line representing the mirror at the point where the incident ray strikes the mirror. This line is known as the normal to the reflecting surface at that point. So figure number 16.2, we can see the angle. Figure number 16.2, drawing the normal here. So this is the line, and this comb-like structure, it shows the back side of the mirror, that is silver coated side, and here we draw the normal that is perpendicular to the reflecting surface. And between the normal and incident ray is called the angle of incidence, that is represented by I, angle I. So the angle between the normal and the reflected ray is known as the angle of reflection. And normal and reflected ray. Normal and reflected ray, that is called the angle of reflection. It is represented by angle R. So measure the angle of incidence and the angle of reflection. Repeat the activity several times by changing the angle of incidence. So enter the data in table 16.1. So in table 16.1, here is the plane mirror, and this is the normal, which is perpendicular to the reflecting surface, and this is the incident ray. Incident ray is the ray which is coming to the reflecting surface, and this is the reflected ray. This reflected ray is the light ray which goes away from the reflecting surface. That is called reflected ray. So angle of incidence and angle of reflection is the angle formed by the incident ray and the normal. This is called angle of incidence, and it is represented by small I. And this is the normal, and this is the reflected ray. So the angle between the normal and reflected ray, this is called angle of reflection. So table 16.1, let's see angles of incidence and reflection. Let's see angles of incidence and reflection. Here, serial number 1, 2, 3, 4, 5, angle of incidence, that is represented by angle I, and angle of reflection, angle R. So here, serial number 1, 2, 3, we can make several angles, several figures, this angle of incidence and angle of reflection. Here it may be 30 degree. Here in the next we can draw in the 65 degree or 35 degree or 45 degree. So we can understand that the angle of incidence, that is angle I, will be equal to the angle of reflection, that is angle R. Angle of incidence and angle of reflection will be always same. So this could be one of the laws of reflection of light. And do you see any relation between the angle of incidence and the angle of reflection? As I told you, angle of incidence will always be same in measure with the angle of reflection. So are they approximately equal? If the experiment is carried out carefully, it is seen that the angle of incidence is always equal to the angle of reflection. So this is one of the laws of reflection. So angle of incidence is always equal to the angle of reflection. So this is one of the laws of reflection. So let us perform another activity on reflection. Here we have to see another activity. What would happen if I threw the light on the mirror along the normal? If I throw the light along the normal line, then the light ray will be reflected back on the same path. When we throw light ray along this normal line, then light ray will be reflected on the same path, this side. So activity 16.2, let's see. Perform activity 16.1 again. This time use a sheet of stiff paper or a sharp paper. Let the sheet project a little beyond the edge of the table, figure number 16.4, and cut the projecting portion of the sheet in the middle and look at the reflected ray. Make sure that the reflected ray extends to the projected portion of the paper, and bend that part of the projected portion on which the reflected ray falls. So can you still see the reflected ray? And bring the paper back to the original. So here, activity 16.2, we have to perform activity 16.1 again, and this time we can use a sheet of stiff paper or a short paper, and we can project the sheet a little beyond the edge of the table. So on doing this activity, the projecting portion of the sheet in the middle, and look at the reflected ray, and you can make sure that the reflected ray extends to the projected portion of the paper, and bend that part of the projected portion on which the reflected ray falls. So Here, let's continue. Here is position. Here is position. Can you see the reflected ray again? Here, what do you infer? Here, can you see the reflected ray again? Here, and here is the figure number A. This is the figure number B, and incident ray, reflected ray, and the normal at the point of incidence lie in the same plane. So here, incident ray, the reflected ray, and the normal at the point of incidence will all lie in the same plane. So this could be one of the law. So when the whole sheet of paper is spread on the table, then it represents one plane. The incident ray, the normal at the point of incidence, and the reflected ray are all in this plane. So when you bend the paper, you create a plane different from the plane in which the incident ray and the normal lie. So then you do not see the reflected ray. So what does it indicate? So it indicates that the incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. So this is another law of reflection. That means the second law of reflection. So in the first law, we learned that the angle of incidence is always equal to the angle of reflection. And here in this second law, what it says, the incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. So this could be the second point, second law. So here, Pahle and Buzo perform the above activities outside the classroom, and with the sun as the source of light. So sun as the source of light instead of a torch. So you too can use the sun as the source of light. So you too can use the sun as the source of light. So here, these activities can also be performed by making use of the ray stick apparatus that is available in the kit prepared by NCERT. Here, activities, so many activities we can also perform by making use of the ray stick. Here now let's continue. In the in continuation of this chapter number, let's see. Buzo remembered that in class 7, he had studied some features of the image of an object formed by a plane mirror. So here, Buzo remembered that in class 7, he had studied some features of the image of an object formed by a plane mirror. Pahle asked him to recall those features. Number 1. Was the image erect or upside down? Was the image erect or upside down? Number 2. Was it of the same size as the object? And number 3. Did the image appear at the same distance behind the mirror as the object was in front of it? And number 4. Could it be obtained on a screen? And let us understand a little more about the formation of an image by a plane mirror in the following way. So here, Buzo remembered that in class 7 he had studied some features of the image of an object formed by a plane mirror, and Pahle asked him to recall those features. And number 1 say, was the image erect or upside down? So features of an image formed by a plane mirror. So the image formed by a plane mirror should be erect and or upside down. The image formed by a plane mirror should be erect And was it of the same size as the object? Yes, the image formed by a plane mirror will be of the same size as the object. And did the image appear at the same distance behind the mirror as the object was in front of it? This is also yes. Actually, the image appear at the same distance. The image formed by a plane mirror, the image will be formed at the same distance when the object lies in front of the plane mirror. And could it be obtained on a screen? No, it could not be obtained on a screen. And let us understand a little more about the formation of an image by a plane mirror in the following way. So let's see activity 16.3. A source of light O is placed in front of a plane mirror, that is PQ, and two rays OA and OC. OA and OC are incident on it, figure number 16.5. And can you find out the direction of the reflected rays? Here, draw normals to the surface of the mirror, that is PQ, at the points A and C. Then draw the reflected rays at the points A and C. How would you draw these rays? Call the reflected rays AB and CD, respectively. Extend them further. Do they meet? Extend them backward. Do they meet now? If they meet, mark this point as I. For a viewer's eye, at E, figure number 16.5, do the reflected rays appear to come from the point I? Since the reflected rays do not actually meet at I, but only appear to do so, we say that a virtual image of the point O is formed at I, as you have learned already in class 6. Such an image cannot be obtained on a screen. So here it means here is the figure number 16.5, image formation in a plane mirror. Let's see. This is the PQ. This is the PQ is the plane mirror, surface of the plane mirror, and this side is the silver coated. That means the back side of the plane mirror, and the above side is the reflecting surface. So O is the object, and its image is formed on the surface AC. So OA and OC are the two rays. They are the incident ray. Here it is represented as like this. And this AB and CD are the reflected ray. And when we draw two perpendicular lines, that is normal at the point C and at the point A. Then here, when we observe from this point, here is the eye, when we observe from this point, then this object O appears to be this eye. Actually, the object is in front of the mirror. And when we observe in the mirror, the image is considered to be at the back side of the mirror. So this image formation is called the virtual image. Now let's continue. You may recall that in an image formed by a plane mirror, left of the object, so appears on the right and the right appears on the left. This is known as lateral inversion. So the image formed by a plane mirror, should be always laterally inverted. That means the object on the right side of the object will appear as the left side in the image. So that phenomenon is called lateral inversion. So there are some characteristics of the image formed by a plane mirror. Then they are: the image formed by a plane mirror is erect, and the size of the image is same as the object, and the image is formed at a distance in which the object lies in front of the mirror, and the image formed by a plane mirror is laterally inverted. So these are the points. So regular and diffuse reflection. Let's see, regular and diffuse reflection. So before we studied about the regular and diffuse reflection, I will give you some knowledge about the image formed by a plane mirror. So let's see it. So you can look at here. We can draw a line. Here, suppose this is the line. Then this side is the back side of the plane mirror. Back side of the plane mirror. This is called what? Silver coated. Silver coated. Generally, because silver is highly reflecting. And this one is, suppose, so when the incident ray comes from this side, when the incident ray comes from this side, then the reflected ray will move in this way. And we can draw here normal. So this is the normal. So this side of the plane mirror is called what? Aperture. Aperture. So this is the incident ray. This is the incident ray, and this is the reflected ray. And this is normal. So here the angle formed by an incident ray and normal, this is called angle of incidence, and it is represented by a small I. And the angle formed by normal and reflected ray, this angle is called reflected angle. That means angle of reflection. So this angle of incidence and angle of reflection will always remain the same. So angle of incidence will be always equal to angle of reflection. Angle of reflection. So this is low one. This is low one. And in the law number 2, in the law 2, what it says? This incident ray and normal at the point of incidence and reflected ray all lie in the same plane. So incident ray, law number 2 says, incident ray, normal at the point of incidence all lie in the same plane. So this is the law 2. And some characteristics of the plane mirror. Let's see. There are some characteristics of the image formed by a plane mirror. The image formed by a plane mirror will always be erect, and the size of the image will be same as the object size. And the third point, the image is formed at a distance equal to the object when the object lies in front of the mirror. And the fourth point is the image formed by a plane mirror is laterally inverted. That means lateral inversion. So in characteristics, so here we can see these are what about the angle of incidence and angle of loss of reflection. So characteristics of, here we can see characteristics of image formed by a plane mirror. Characteristics of image formed by a plane mirror. Let's see. Point number 1. Say the image should be erect. And point number 2. What to say? Point number 2. Image should be object should be same size. Image should be same size as the object. And point number 3, image appears at the same distance behind the mirror. Image appears at the same distance behind the mirror. And point number 4, image is laterally inverted. Image is laterally inverted. Image is laterally inverted. So these are the few points. So now we learn about the image formed by a plane mirror, characteristics of image formed by a plane mirror, and angle of incidence, angle of reflection, loss of reflection we have learned. Now let's learn regular and diffuse reflection. Regular and diffuse reflection. Activity 16.4, let's see. Imagine that parallel rays are incident on an irregular surface as shown in figure 16.6. Remember that the laws of reflection are valid at each point of the surface. Use these laws to construct reflected rays at various points. Are they parallel to one another? You will find that these rays are reflected in different directions. Figure 16.7. So here, figure 16.6, parallel rays incident on an irregular surface. So this surface is irregular. So when the incident rays are parallel rays incident on an irregular surface, then how they reflect? The rays reflected from irregular surface, it will reflect on different direction. We can see here, these are the reflecting rays. So when all the parallel rays reflected from a rough or irregular surface are not parallel, so the reflection is known as diffuse or irregular reflection. And remember that the diffuse reflection is not due to the failure of the laws of reflection. So diffuse reflection is not the failure of the laws of reflection. It is caused by the irregularities in the reflecting surface. So on the other hand, reflection from a smooth surface like that of a mirror is called regular reflection. So figure number 16.8, images are formed by regular reflection. Images are formed by regular reflection. Here, figure 16.8, regular reflection, we can see here. These are the incident ray and these are the reflected ray. You can see. So do we see all objects due to reflected light? Here let's see. Do we see all objects due to reflected light? Nearly everything you see around is seen due to reflected light. Moon for example, receives light from the sun and reflects it. That's how we see the moon. The objects which shine in the light of other objects are called illuminated objects. So can you name some other such objects? Here there are other objects also which give their own light, such as the sun, fire, flame of a candle, and an electric lamp. And their light falls on our eyes, and that is how we see them. The objects which emit their own light are known as luminous objects. Here I have a question. Can the reflected rays be further reflected if incident on another mirror? Yes, that also can reflect. Let us find out. Reflected light can be reflected again. Here, let's see. Recall the last time you visited a hairdresser. She or he makes you sit in front of a mirror after your haircut is complete. She or he holds a mirror behind you to show you how the hair has been cut. Figure 16.9, we can see. Do you know how you could see the hair at the back of your head? Figure number 16.9, mirror at the hairdresser shop. Here, you can see the back side of your head. When one mirror is in front of you, big mirror, and at the back side of you, another mirror is there, then the image formed in the back side mirror will fall on the front mirror. That's how we can see our back side. This is how reflected light can also be reflected again. That's why image of the back side of the head is formed on the image on the mirror that is on our front. So here Pahle recalls having constructed a periscope as an extended activity in class 6. The periscope makes use of two plane mirrors. And can you explain how reflection from the two mirrors enables you to see objects which are not visible directly? So periscopes are used in submarines, tanks, and also by soldiers in bunkers to see things outside. So, periscope is one of the devices which is used in the submarines, and particularly they can see soldiers can see things which they cannot see from inside. So in this way, plane mirrors are used in the construction of periscope. Multiple images, let's see. You are aware that a plane mirror forms only a single image of an object. What happens if two plane mirrors are used in combination? Let us see. Activity 16.5, let's see this. Take two plane mirrors, set them at right angles to each other with their edges touching. Figure number 16.10. To hinge them, you can use adhesive tape. Place a coin in between the mirrors. How many images of the coin do you see? Figure number 16.10. Images in plane mirror at right angle to each other. Here. Now, hinge the mirrors using the adhesive tape at different angles, say 45 degrees, 60 degrees, 120 degrees, 180 degrees, etc. Place some object, say a candle, in between them. Note down the number of images of the object in each case. Finally, set the two mirrors parallel to each other. Find out how many images of a candle placed between them are formed. Figure number 16.11. You can see figure number 16.11. Image in plane mirror parallel to each other. So here, image in plane mirror parallel to each other. This is the plane mirror here. So we can see Can you now explain how you can see the back of your head at the hairdresser shop? So this idea of number of images formed by mirrors placed at an angle to one another is used in a kaleidoscope to make numerous beautiful patterns. So you can also make a kaleidoscope yourself. So here for today, let's stop here. In the next video class, let's continue again for this same chapter. For today, bye.